We're at the bottom of page 4. So now that we've gone over an example of how to expand using Pascal's triangle, let's try this one more time. Expand 2y plus 3 to the exponent 6. So the first thing you should do is look at row n equals 6 for your coefficients. And take a look at your previous page. Your coefficients should be 1, 6, 15, 20, 15, 6, 1. Okay, just make sure you have 7 terms in total. 1, 2, 3, 4, 5, 6, 7. Good. All right. And now the exponents on the first term 2y, they'll start with 6 and then they will decrease by 1 going to the right. The exponent on 3 will start with 0 and then it will increase by 1 going to the right. So what I'm going to do is I'm going to just write in the coefficients first. Leave some space. Oops. And then I'm going to fill in my powers of 2y and powers of 3. So first with 2y 6, 2y 5, 2y 4, 2y 3, 2y squared, 2y to the exponent 1, and the last term will not have an exponent of 2y, because 2y to the power of 0 is just 1 anyway. Okay, and then 3 to the power of 0, I'm not going to write anything. 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of 5, and then 3 to the power of 6. And just make sure that when you check over your terms that each of the exponents in every term, they add up to 6, which they do. Good. And now just expand everything and simplify. Go ahead. And when you come back, I'll give you the answer. Okay, I just wanted to show you this middle step. So I've almost collected my coefficients together. I just need to multiply them out. But as you can see, I have y6, y5, y4, y3, y2, y1, and no y for the last term. Okay, simplify fully. And there we have it, the last final step. And believe me, this is a lot faster than expanding it traditionally. All right, for the last example, state the fourth term of the expansion 3y minus 2 to the exponent 7. There's a couple of ways you could do this. If you want, you can expand it all out. If you want some extra practice using Pascal's triangle, go right ahead. I will write out the final answer for you there if you pause your video. And also I'm going to show you one other way after that. Sorry, I couldn't quite fit everything perfectly into one line, but here is the final long string of the expanded form. And now the fourth term would be 1, 2, 3, 4. So you could say, therefore, the fourth term is negative 22,680 y to the exponent 4. Now there is a shortcut to doing this. You can start writing out the row n equals 7 coefficients again, 1, 7, 21, 35. So now that you've reached 35, that's your fourth term. And then you know that the exponent on 3y is going to be 4. And you know that the exponent on negative 2 has to be cubed because 4 plus 3 has to equal 7. So if you put that all together, then you can say it's 35, 3y, 4, negative 2 cubed, and then simplify that to get your fourth term. And you end up getting the exact same answer. You might be wondering, how do we know that this exponent has to be 4? Well, because we know that that must go with the fourth term. And that's what we need in this question. All right, so that's it for binomial expansion, and that is it for this unit. Congratulations on completing a successful unit of flipping the classroom. The last video is just the unit outline.